In our onStart method for this activity, we set up the location provider that's going to feed us the GPS data, and we also obtain the power manager that we'll use to prevent the device from going to sleep during tracking of a route. Now, in order to get the proper location provider, the first thing we do is create a criteria object and configure it, and we'll use this as part of requesting that the Android operating system give us back an appropriate location provider. Now, as you can see here, we're calling various set methods on the criteria object, starting with, in this case, set accuracy, and we've specified that we want the fine accuracy, which basically indicates that we want high accuracy GPS data. And by the way, you should be aware that GPS data requires more power to obtain as well. Now, if you don't need fine location data, precise location data, you could do accuracy underscore coarse here, or in Android 2.3 and higher, you can take advantage of newer constants which are called accuracy underscore high for GPS, and accuracy underscore medium, and accuracy underscore low as well. Now, the next thing we specify is that we need bearing data. Bearing data helps us determine the direction that we're traveling, and this is what we will use to orient the map so that the direction we're traveling is always pointing towards the top of the screen. The next thing we have is set cost allowed, and we're setting that to true. Now, if you set cost allowed to false, basically what that would mean is that you don't want the app to use data services that would result in charges to the user. Now, of course, when you're out and about and using GPS data, you're not often near Wi-Fi hotspots, and therefore if you want map data which has to be downloaded over the internet, then you're going to have to take advantage of data services for the app to work correctly. So we've said that we're setting cost allowed to true, and in fact if you're going to do this, you should first prompt the user in a real app with a dialogue asking them if it's okay to do this. You should not just simply assume that it's okay. Next, we set the power requirement, and we're requesting low power if we can get it so that we use the minimum amount of battery possible. And finally, in this case, we're also setting altitude required, in this case to false, because we're not going to use altitude data. If we wanted this to be a very precise tracking of our route so that we can tell, for example, how far we've really traveled, then we would probably want to use altitude data. As you know, if you're going up a steep mountain, you may not be proceeding very far as the GPS data goes, but you could be going very high as far as altitude data goes. Therefore, you would have different calculations to properly track your route. For the purpose of this example, we assume that your route is actually flat. Now, once we have the criteria, we go and use the inherited getSystemService method to acquire a location manager object. Then we say that we want to register a GPS status listener, which is going to help us determine if we've gotten the GPS fix, that is, that we know we're communicating properly with GPS satellites. And then through the location manager, we invoke the getBestProvider method, and we hand it two different pieces of information: the criteria object that we configured up above, which is used to specify the features that we need in our location provider, and then separately the argument true says to only give back a location provider that's actually enabled, and that's important because if it's disabled, obviously you can't get any data from it. The next thing we do is say that we would like to start getting location updates. So now we want to obtain data from the location provider. We specify as the first argument the string that was returned by the getBestProvider method. Then we have two additional arguments of 0 that are used to specify the minimum time between data being sent to the app, and then separately the minimum distance traveled before you get a new location. Now, by setting these to 0, what you're saying is you want to get as frequently as possible new GPS data information so you can precisely track information, and in general you want these values to be positive numbers in real apps, again because using GPS data requires a lot of power, and you want to minimize the amount of power that your app actually uses. For demonstration purposes, we've chosen to use 0 for both of these here. And then finally, we specify the listener that's going to be responding to those events. And as you can see here, it is an object of type location listener, which will receive the location updates. Now, at the end of our onStart method here, we get the system service that's called the power service, which gives us back a power manager object. Then we say that we want to create a new wake lock, and a wake lock is basically going to allow us to control whether or not the device goes to sleep. In this case, we say a partial wake lock, and for a partial wake lock, we're basically saying that the app should continue to use the CPU of the device even if the user presses the power button to turn off the screen on the device. The next thing we do at line 118 is acquire the wake lock, which now allows the app to prevent the device from going to sleep effectively. And then finally at line 120 we say to our bearing frame layout to invalidate, and what this does is it causes the bearing frame layout to draw itself on the screen, and this is where our map data will first get displayed on the screen. Now when the onStop activity method gets called, we're going to be releasing the wake lock, because as long as the app is not in the process of tracking a route, we would like to allow the device to go to sleep.